Right. So lastly, we looked at solving equations. Right. So in algebra, there's something called an expression and there's something called an equation. Right. And we need to recognize the difference between the two. Right. And the expression is simpler. Right. And the equation is a little more complex because it has a left hand side and a right hand side. It has an equal sign as well. Right. With that expression, it do have an equal sign and we could only simplify basically. Once it have like terms in an expression, we can simplify and that is it. Can't go further than that, right? Nice. With the equation now, we could solve for the unknown. So the unknown takes a specific value, a specific number, right? So here x represents 2. Some number plus 5 equals to 7. That number x is 2. Next case, some number plus 6 is equal to 10. That number x is 4. 4 plus 6 is 10, right? And you realize x takes a specific value in every equation, right? We looked at some more examples, but in these examples here now, right? All these examples we did last class, we looked at the law, a little law here to help we solve it, right? So I put this law here to guide you along to solving equations of this form. So the law is when a variable has a number added to it, so when any variable, right? For example, we do a fresh example here, right? So when a variable, the variable will have to be x, it could be anything. For example, let's say, okay, y has a number added to it, y plus 13 equals to whatever, like we say minus 3 or something, right? So when a variable, right, follow me down here, right? For a new example here, has a number added to it, any number added to it, what we just do to solve this variable, to solve for this variable, to solve this equation, we just subtract that number. So you don't take this number and subtract it on the other side of the equation. So y is equals to minus 3. Instead of add 13, it's going to become subtract 13. And here y is equals to same signs, and keep the same sign minus 16. So y is equals to minus 16. And that is the answer to this equation, right? Good. Minus 16 is the value for y in this equation here, right? We could do a simple example here, right? For example, let's say I have x plus 2 equals to 12, right? Some number, when you add 2 to it, you get 12. We know the number is 10 because 10 plus 2 is 12. But the law to it is when a variable has a number added to it, we subtract that number on the other side of the equation. So x is equals to 12, subtract 2, x is equals to 10, right? So you understand this law perfectly well, right? This law is very simple, right? Last day we looked at many examples. We just want to cover back a few today, right? So let me just, I'm going to do, let me say 4. Let me do 4 examples here quickly, right? Nice. First one, when a variable has a number added to it, we subtract that number on the other side of the equation. So x is equals to 8 subtract 3, x is equals to 5. Nice. 5 plus 3 is 8. You can double check it if you want, right? Next one, I'll do number 7 here. When a variable has a number added to it, right? X has the number 13 being added to it. We subtract this number on the other side of the equation. X is equals to negative 8. If you realize the right hand side stays the same, the right hand side here was positive 8. It remains the same. The right hand side here is negative 8. That remains the same, right? The only thing that changing is really the term that moving from one side of the equal sign to the other side. So positive 13 becomes negative 13. So x is equals to, here now we need to think, we gotta subtract here. We don't need to subtract here. So when we say subtract on the other side, we don't literally mean one subtract two numbers, right? This number was added here, so it becomes subtract on the other side, right? But we need to follow the law of direct numbers, which is same signs are keep the same sign, right? Remember the same signs law? Same signs are keep the same sign, like minus 2 is equals to minus 4, minus 3 minus 2 is equals to minus 8. Add and keep the same sign, right? So here we're going to add and keep the same sign. 13 and 8 is how much? 21. So negative 21 is the answer here, right? I do the next one. X plus 5 equals to minus 3, right? X is equals to minus 3. Take away 5, right? We use same signs law here. Same signs means to add and keep the same sign, right? So we say this is minus 8, right? That was simple. And let me see this one over here now. Number 10, right? X plus 17 equals to 9. If you want to put the sign by 9 here as well, to indicate that it's positive, right? The right hand side, nothing changes in the right hand side, right? Everything remains the same. So x is equals to 9, which is positive 9, of course, take away 17. So you see, I can circle the term I'm moving across, right? Good. Especially if you're in Form 1, right? And now we're accustomed to this law here, right? Circle the term and throw it across, right? Now we need to use different signs law here, right? Subtract and keep the bigger sign. We did this law very early in the term, right? So what is this here? This is minus 8, okay, minus 8. So all these equations here, we solve them successfully and we obtain the solution. So the answer here is called the solution to the equation, right? So you might want to take note of this, right? Right, these are called the solution to the equation, right? The answers are called the solution. Solution to the equation, right? Sometimes in maths, you can see we write the solution as SQL apostrophe N, right? To solution to equation. We will spell out the word equation. Sometimes you write EQ apostrophe N. Solution to the equation, right? So when you solve an equation, we just obtain the solution to the equation, right? So you can take note of that from that because we already have all these examples in the book, right? This was the practice exercise from last class, and we have the law. We have the law in the books already. So this is just to revise that law, and now we want to go on to the second law to solve an equation today, right? Good, because most of you all in Form 1, we're not gonna do 2 and 3 laws in one class, right? We do one law, understand our law, practice it. Next law, understand our law, practice it, and then we're going to practice questions, and then now we need to identify whether it's the first law we're using, the second law we're using. It will come naturally to we as long as you understand what we're doing here, right? Good. So the first two laws are highly similar, related to each other, right? So we're going to look at the second law now, right? So again, this is just a revision, everything here on the group chat folio, and you will have these exercises in your book already, right? Nice. So we're going back now to the whiteboard here. Right, so we could call this the second law of solving equations, right? Because we did one law already, right? So the second law is when a variable, very similar to the first law, as I said, has a number subtracted to it. When a variable has a number subtracted to it, we add that number on the other side of the equation. Right? Equivalent short for equation, right? So let's look at the keywords here. So when a variable, again, we want to solve for the variable has a number subtracted to it. So let's see how that is look here, right? So let's say the variable is x has a number being subtracted to it. What's a number subtracted to it? X minus 2, right? Equals to, let me say 10, right? Good. To solve this equation, we're going to add that number on the other side of the equation, on the other side of the equation, right? Good. So we're going to look at a few examples here, well, right? So all these examples on them, you're going to see we have a variable, a number subtracted to it. So we're going to do what with this number? We're going to add this number on the other side of the equation. X is equal to 10 plus 2, right? This one here, x is equal to 15 plus 3, right? So this is equals to 12, and here is equals to 18, right? So think about it. When a variable has a number subtracted to it, we add that number on the other side of the equation, right? The right hand side number remains the same, right? You could keep it as whatever sign you had there before, and we're good to go, right? Nice. Another example here. When a variable has a number subtracted to it, right? We add that number on the other side of the equation. So here, x is equals to minus 5, and it is being subtracted here, so we add it on the other side, right? Good. All that's left now is to apply the same signs law or different signs law, right? Different signs law here, add and keep the bigger sign, subtract and keep the bigger sign, sorry. So this is plus 3, right? So you take away, right? You find the difference here and keep the bigger sign, right? 8. Next example here. x minus 7 equals to minus 16, right? Good. X is equals to minus 16 plus 7. Negative 7 becomes plus 7. So x is equals to, again, different sign, subtract the bigger sign. This is minus what? 9. Yeah, minus 9. Are we good to go there? So we know how to solve our equation now when, as before, the variable has a number added to it, and when the variable has a number subtracted to it, right? So what we could understand here, we're gonna make a little conclusion here after you all take this down, right? So I'll give you a chance to take this down, and we're going to look at a little conclusion here to summarize both laws, right? And then we're gonna do some practice. Right, so I'm gonna give you a little practice exercise to look at, right? Start them, and remember, when you're doing anything new in maths, look back at your examples on them, right? And whatever notes you have on it, you feel free to look back at it, right? Anyway, you're going to learn it, and the more you practice, the easier it will be. You don't even have to look back at your notes afterwards, right? So once you do sufficient practice questions, you're good to go, right? Because this is a fairly easy law, but when you do the first few, look at the examples on them, right? So go ahead, and the instructions are simple. For all this, since you're doing solving equations, the instruction you're going to see the word solve. Solve the following equations, or solve for the unknown, or solve for the variable in the following, whatever it be. Once you see the word solve, we know we're using the laws of solving equations as well as the laws of direct numbers come into play here, right? To solve the following equations. All right, let's be careful with your signs, your laws of direct numbers, and the final step, right? Good. And just remember, there's also another way to solve this besides using the law, right? What way is that? Well, I do the first one here, right? So most of you probably finished the first one already, right? Nice. So we could say what number, some number, x is some number, we don't know what the number is, right? Right? But when you take away 2 from the number, you get 3. What number when you take away 2, you get 3? The number to be 5, because I know 5, take away 2 is 3. So x had to be 5, right? So the first one here, x is equals to 5. But if you use the law, right, we could also get the same answer. When a variable has a number subtracted to it, we add that number on the other side of the equation. So x is equals to 3 plus 2, x is equals to 5, right? Point to note again, students. When some students doing it, sometimes they tend to move across the 2, leave the 2 as minus, and change the 3 to be minus instead, right? Whatever the right hand side signs are, that number stays the same. So if it's positive, it remains positive throughout the question, right? Nice. The only thing that really changing is the term you're moving across, right? You turn it, you trans sign. The reason why you want to get rid of this term here, because you want to solve for the unknown. You want the unknown to be by itself. X here, you want this to be by itself, right? So nice. So that's the answer for the first one here, and we have our working. We have some examples again to follow from before. So go ahead and look at that, and we correct them shortly, right? Okay, nice. So now that most people finish, we could go ahead and correct, right? So again, look back. You see the pattern here, right? When something is being subtracted to the variable, right? We add it on the other side, right? And to make the movement a little easier, a little smoother, you see you don't want to interfere with this -5 here. This -5, you want that to be -5 always throughout the question, right? Because this is really changing sides or anything. This will be made in here, right? But the term that really changing the sign is the one that you're really shifting. You're shifting it across. See this here? So we circle it and we carry it across. So that's a good way to, when you know starting off equations, you can circle the number and draw your arrow to show it going across, right? So number 2 here, right? 6 is being subtracted here. So we add it on the other side. We want to add it on the other side, right? So x is equals to 10 plus 6, right? If 10 is positive, that remains the same. So this is 16, right? Or positive 16, same thing. X1. X is equals to 6 plus 5. This is 11, right? Number 4, right? We're going to add this on the other side. So we say x is equals to 10 plus 8. X is equals to 18, right? So the first one was pretty simple to get accustomed with the law. And the rest now, you can see the laws of directive numbers coming into play here now, right? Right, so let's look at them carefully. So x is equals to -7 plus 3, right? Different sign, subtracting the bigger sign is -4. X is equals to -10 plus 8. Different signs again here. So subtract, keep the bigger sign. X1, we shift across the 9. -12 plus 9, right? Different signs, subtract, keep the bigger sign. -3. Go again here, right? 15 is being subtracted from x. So we're going to add 15 on the other side. So the 16 remains -16, and we're going to change it to positive 15, right? Different signs here, subtract the bigger sign. Nice, we're good to go here, right? Last section now. Right? 8 going to be what? Right? So our volunteer to do number, Sajid, you can help me with number 10, right? And Kyla, you will help me with number 12, right? Number 11. So I want volunteers to do these two for me, right? So I'm going to do number 9. So we have here x subtract 8 equals -2. So x equals to -2 plus 8. Now we apply different signs law here. Subtract keep the bigger sign, so this is plus 6, right? Nice. So go ahead, Sajid.
X is equal to -4 plus 6.
-4 plus 6. What is the answer?
2.
Positive 2 or -2?
Positive 2.
Positive 2. Nice. Good. Because we applied different signs law here, right? Good. Nice.
Yeah.
Kyla, number 11.
Yeah, x is equal to -3 plus 7, which is positive 4.
Excellent, go Kyla, right? Good. Positive 4. So you're still doing this in school, Kyla? You do more than the topic.
We're still doing this in school.
All right, nice. Good. So a little revision for you. All right, so we have here now number 12, right? X minus 10 equals -10. Take your time, follow the law. When you transfer this on the other side, x equals to -10 plus 10, right? Think about this one here now. What's going to be the answer here? Right? Well, this is different signs. Subtract. We're going to subtract and keep the bigger sign, right? But it have no bigger sign here because both of them carries the same value, right? 10. 10 is the same value in both cases. Just one positive, one negative. So they both have the same weight. They both weigh the same, right? Whereas up here now we can say 7 now way more than the -3, right? Over here the -12 way more than the 9, right? Always negative is way more. In this case here now, all we do is we subtract and keep no sign. So 10 take away 10 is 0. And 0 carries not a negative, neither a negative, nor a positive, right? Right, students? So we're good to go there. So let's be careful of that. And remember your laws of directed numbers. Number 1, and remember your laws of solving equations, right? So what we go on to here to do now, we're going to look at the two laws on them and see side by side how they operate, right? So the first law which we did last class and the second law which we did today. When a variable has a number subtracted to it, we add that number on the other side. We need to look at those two laws side by side here, right? So let's pay attention to what going to take place here. All this will be sent in a group, so don't worry if you miss any corrections or anything. I'll send it in a group chat for you, right? Nice. All right, so look at this here now, right? So let's look at our example here, right? So x take away 2 equals to 10, right? And then we have here x plus 2 equals 10, right? We have two questions here side by side, very similar, right? But both of them involve the use of different laws, right? The two laws we learned so far, right? Nice. So let's just summarize here. The second law we learned, which is the most recent law, is when anytime a variable, you see a number subtracted to it, right? All we do is we add that number on the other side, right? So x is equals to 10 add 2. X is equals to 12. And just to recall, this is called the solution to the equation, right? Solution to the equation, right? Because x could not take any other number here, right? X can take 3, it can be 4, it can be 5. In this case here, x must be 12 to make the statement true. This is a mathematical statement. The equation, in other words, is a mathematical statement, right? Consisting of two sides, a left-hand side and a right-hand side. So we understand our definitions from last day when we did the laws of when we did what the equation is. So now, if you was to replace x here with 12, 12 take away 2 is 10. This 12 makes the statement true. 12 makes the statement true, right? It makes the statement appear true. Good. No other value could come here but 12, right? 12 minus 2 is equals to 10, right? Nice. And which law we use here? We transfer the 2 on the right hand side, and from negative 2 it became positive 2. So we see that in action as well, right? So pay attention to the next side here now. What? X add 2 equals to 10. When a variable has a number added to it, what we're going to do, we're going to subtract that number on the other side, right? So you see how this law is different from that law. So you see 10 subtract 2. So you see negative 2 became positive 2 on the other side, and in this case, positive 2 became negative 2 in the next side, right? So we need to be careful here, right? And in both cases, the 10 remain the same, right? So x is equals to, right? 10 take away 2 is what? 8. 8. 8 here is the solution to this equation, right? So 8 plus 2 is 10. Let's verify that. Yes. 8 add 2 equals 10, right? Nice. So we see the two laws side by side here. Be in action, right? So now, forget about the laws now. We need to understand how to solve equation. So we need to learn a general way now to solve any equation once it consists of these two laws here, right? So forget about the laws. If you don't know the laws, you don't want to learn it as laws, learn it as this here now, right? So these are the two operations we covered so far, right? So we have addition operation and we have the subtraction. So be mindful of these two things here, right? When a variable has some operation being done to it, what we just do on the other side is the inverse operation. Right? So when I say inverse operation, when something has a number added to it, we're going to subtract on the next side. When something is being subtracted, we add on the next side, right? So you do the inverse operation on the other side. And this is how simple it is. Negative 2 became positive 2 in the process of solving for x. And here positive 2 became negative 2 in the process of solving for x, right? So when something is being added, you shift it across, it becomes the inverse of added. The inverse of adding is subtracting. Similarly, when something is being subtracted, right, and then shift it across, it becomes the inverse operation of subtraction, which is addition. So addition and subtraction are the inverse operations of each other, right? So once you understand this here, right, we could solve any equation now, right? Once it have these two laws in it, right? So for example, x minus 3 equals to, let's say, minus 15, right? Nice. No problem here, right? What is being done to x here is subtracting, so you're going to do the inverse of subtracting. So you're going to shift the addition, right? Minus 15, add 3, right? And obviously here is different signs, let's subtract the bigger sign, minus 12, right here. We're good to go, okay? Nice. Next example, x plus 5 equals to, let me see something like negative 3, right? Good. So what is taking place here? X is being added to 5. So we're going to do the inverse of adding 5, subtract 5 on the other side. So minus 3, take away 5, same signs, and same sign as minus 8 here, right? Nice. So this here now, once you understand this table here, you understand the laws and them a little more in detail, right? And we still have the two laws them in written form, right? That's to help with the guide we. But now this table here now is what we want to put your attention to now, right? Good. So once you understand this table here, right? And you could draw your circle and show I think shifting it across. Right? So I want you all to take this down, right? And just remember we do the inverse operation on the other side, right? We do the inverse operation. Inverse of the operation on the other side, right? Right? Next, I have a small note here, and I'm going to give all you a mixed exercise to do to close up class study, right? So the mixed exercise means you're going to get a series of questions and you are to determine which law to use, right? Next, I'm waiting for you to take this down and I'll give all you the question. Right, so when I finish, I'll see you all in next week, right? So remember, we did a new law today, but we understand a way in which we could solve any type of equations, right? Either one of the laws, right? So practice this, and just remember, when you're doing the laws and them, is the term that you're moving, shifting the sign. The right hand side remaining the same, right? No matter what, right? So when I finish, I can leave. I'll see you next week, Saturday at 9 a.m.
Assalamualaikum, sir.
Walaikum Assalam.